In this video, we're going to look at multiplication and division application problems. So we have seen the connections between multiplication and division as shown in the table below. So here are different problem types we saw in applications. Here's how we might find them using multiplication. Here's how we might find them using division. And it's a little bit easier if you know it's a multiplication or division problem. So now we want to look at some problems where we may not know whether it's multiplication or division, and it may be set up in a form that we really need to analyze and interpret. So let's look at some problems. So Sarah bought 3 boxes of chocolate. There were 18 pieces of chocolate per box. And we want to know how many chocolates, did she buy? We know she bought 3 boxes. Okay. May be really tempting just to go ahead and divide here. I actually do this on purpose. I made it 18 divisible by 3. I use numbers where dividing would give you a whole number. And so you'd really have to think about the problem. Okay. So it always helps to either draw or to try to imagine in your head. A lot of students don't like application problems, but it's really giving you an opportunity to visualize and imagine what's happening here. So you can imagine the 3 boxes of chocolates. Maybe they look like this. Okay, and now it says there are 18 pieces per box. Okay, pretend that's 18 and there's 18 in each box. We want to know how many chocolates did she buy. Okay, so notice we're going to have 18 plus 18 plus 18, or 3 copies of 18. So we have 3 boxes times 18, I'll put CH for chocolate, chocolates per box. Okay. And notice the boxes cancel, so we multiply 3 times 18, which is 54 chocolates. And again, the unit analysis using the units of measure isn't really necessary, but notice how nice it is that it really shows you that you set the problem up correctly. So we wanted to find how many chocolates. That's what we found. If we had divided it, we actually would have gotten square boxes divided by chocolates. It would have been something that was nonsensical. Let's look at the next one. Each batch of cookies requires 4 cups of sugar. If Thea has 12 cups of sugar, how many batches can she bake? Okay, so again, draw a picture, visualize it. So each batch of cookies requires 4 cups of sugar. Okay, but then I see she has 12, so I know she has them, so I want to draw them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. In my mind, I could see the see-through cups filled with sugar. There's 12 of them. Each batch requires 4 cups. So 1, 2, 3, 4. That's 1 batch, and 3 batches. Okay. So again, notice I partitioned or broke the 12 cups into groups of size 4, and that's going to be division. 1 batch, 2 batch, 3 batches. Symbolically, we would say 12 cups divided by 4 cups, no, not cubs, cups per batch. Well, 12 divided by 4 is 3. The cups cancel, the batch remains. So 3 batches of cookies. Let's look at the next one. Carmen's airplane ascended 200 meters in 4 minutes. How many feet did it ascend per minute? Okay. So do we multiply these? Do we divide these? Let's think of what this might look like. So maybe you can imagine a plane. Okay, sorry, it looks like a fish. I don't know how to draw a plane. Okay, and it ascended, so that means it went up 200 meters. And it did this in 4 minutes. And we want to know, oh, this should say how many meters, not how many feet, excuse me. You don't have to convert. How many meters it ascended per minute. So assuming this went up at a constant rate, okay, we want to break this 200 into 4 equal pieces, and that's how much it would be per minute. So I'm thinking of breaking it in half, that's 2 pieces. Break the halves in halves, that's 4 pieces. So I'm dividing the 200 into 4 equal groups. Okay, so 200 meters divided by 4 minutes. Okay, and also notice if we put 200 meters over 4 minutes, 200 divided by 4 is 50, and this is meters per minutes. Meters over minutes is meters per minute. Okay, and notice that's the result we wanted. How many meters did it ascend per minute? Okay, let's look at the last one. Greg drove 55 miles an hour for 11 hours. How far did he drive? Okay, again, do you want to say the answer is 5? That's because I did this on purpose, so it looks like you just divide. But I want you to think through them, okay? Sometimes you will have to divide, but just not in this case. So you could think of time as starting here. In 1 hour, he drove 55 miles. In 2 hours, he drove another 55, which would be 110. Okay, and this is going to happen 11 times, which I'm not going to draw. But notice we want 55 miles, we want 11 copies of that. So in 11 hours, he's going to go 55 miles an hour each of those 11 hours. Okay, notice this is also a distance equals rate times time problem. Okay, so the distance, how far he drove, is 55 miles per hour times 11 hours. Okay, notice the hours will cancel and we'll just be left with miles, and that's how we measure how far he drove. And so we need 55 times 11, well that would be 550 plus 55, which is 600, and you could do that on your calculator or by hand, which is 605 miles.